Methods of preparing hydrogen. Water and active metals. Hydrogen can be prepared by the action of water on metals. Very active alkali metals and alkaline earth metals, such as sodium, potassium, and calcium, react with water at room temperature, evolving hydrogen. You can see the reactions of both sodium and calcium with water to produce hydrogen gas shown. The above reaction is vigorous and exothermic, causing the hydrogen to catch fire. In order to slow down the process, the metals are made into an alloy with mercury. These are known as amalgams. An ignition of the hydrogen is avoided, allowing it to be collected. Water and less active metals. Less active alkali metals such as zinc, magnesium, and aluminum react in boiling water, liberating hydrogen. You can see the reaction of aluminum with water to produce hydrogen. Still less reactive metals such as iron, tin, and nickel react with steam, as shown here, to produce hydrogen. Electrolysis of water. High purity hydrogen gas can be produced by the electrolysis of water in presence of small amounts of an acid or base. Hydrogen is collected at the cathode, and oxygen is collected at the anode. You can see the cathode here where the hydrogen is bubbling and those bubbles can be collected, and at the anode where the oxygen is forming and then bubbling, that oxygen can be collected. Using an acid or base. Using base, metals like beryllium, zinc, tin, and aluminum react with boiling alkali solutions, liberating hydrogen. You can see beryllium with the base sodium hydroxide resulting in hydrogen. Using acid, metals which are much more reactive or electropositive than hydrogen, above hydrogen in the activity series, such as zinc or magnesium, react with dilute mineral acids to liberate hydrogen, as shown here. Hydrogen preparation in the lab. Reaction of zinc metal with dilute sulfuric acid, H2SO4, will liberate hydrogen. Zinc plus sulfuric acid will produce zinc sulfate and hydrogen gas. This is usually done in a Wolf's bottle. Granulated pieces of zinc are placed in the bottle and are covered with water. You can see that here. Concentrated sulfuric acid is slowly poured into the thistle funnel here. This is a thistle funnel assembly. The acid gets diluted when mixed with water. Remember, the water is covering the zinc pieces and reacts with zinc to produce hydrogen gas. The gas is collected by the downward displacement of water. Hydrogen preparation in industry. In industry, superheated steam is passed over heated red hot coke at 1,200 Kelvin. A mixture of carbon monoxide and hydrogen gas, known as water gas, is formed. Hydrogen is removed from the mixture by either liquefaction or the Bosch process. Carbon monoxide liquefies at 83 Kelvin, while hydrogen gas liquefies at 43 Kelvin. When the gas mixture is cooled under pressure, CO liquefies while hydrogen gas passes out. In the Bosch process, water gas is mixed with twice its volume of steam. The mixture, when passed over a heated catalyst, usually oxides of iron, chromium, etc., at 773 Kelvin, will be converted to hydrogen gas and carbon dioxide. When electricity is cheap, the electrolysis of water is the best method. An iron sheet is used as the cathode, and a nickel-plated iron sheet acts as the anode. An asbestos diaphragm prevents the mixing of hydrogen and oxygen as it's produced. Partial oxidation of hydrocarbons from petroleum or cracking of natural gas is another industrial method of producing hydrogen. The reaction below applies to the oxidation of alkanes. So an alkane can be oxidized in the presence of steam to produce carbon monoxide and hydrogen gas, where N is the number of carbon atoms in the hydrocarbon. Large quantities of hydrogen gas are obtained as a byproduct in some industrial processes, such as petroleum cracking, manufacture of sodium hydroxide, and electrolysis.